most of the participants. There's going to be a bit of repetition here, but this is the kind of background framing, a bit of a description as to who we are as EFH, why we're holding this hackathon, kind of the big picture questions we're wanting to try and address. And then I'll give a brief primer on some of the data you'll be working with, some of the papers you'll be working with over the next 3 days, and then hand over to Geoffrey, who's going to dive into the specifics in more detail. So the title for the hackathon for the next 3 days is Making Evidence for the Health Impacts of Environmental Change More Accessible to Project Developers and the Financial Sector. And this is really getting at the heart of what EFH, Ecosystems, Finance and Health, is about, which is how do you bridge this knowledge to action gap when it comes to science on health and how the environment is affecting health, and being able to provide that in an accessible way to people who need to make decisions about how the environment is managed and how people's health is managed. So we're a new initiative. We're about a year old in a week or two. So we started, March last year. The kind of core partners for this hackathon are listed here. There's about another 30 other organizations who we work with, some more closely than others, across the sustainable development world, across the financial sector, the academic sector, both in Africa and the US. Oops. Let me switch off my WhatsApp. Back to full screen. So, why health and why the environment? So, this is a county referral hospital up in Samburu. When we tend to think about health outcomes and people's health, we tend to think about burdens of disease in clinics, and that's where a lot of health-related policy and research is focused. It's on epidemiology, of trying to understand patterns and how and why people present to with burdens of infectious disease, non-infectious disease at clinics. But in reality, a lot of the determinants of those disease patterns, whether it's diseases, zoonotic diseases like COVID, or it's non-communicable diseases, mental health, cardiovascular disease, actually sit upstream. So it's in how we as human populations interact with our environment, whether that's in cities and urban environments, whether it's interactions with livestock in cities or in rural areas, whether it's interactions with biodiversity and nature. So what we're really interested in looking at is reaching kind of upstream of clinics and trying to better understand how people's interactions with the environment and how that environment is changing is shaping burdens of disease. And this is really borne out in numbers. So at least 80% of human pathogens, so that's all human pathogens, have some form of environmental mediation. So some step in the process in which they infect people is mediated by the environment. And as a result, about 30% of global deaths are due to modifiable environmental factors. So as a result, reaching upstream and kind of looking and framing sustainable development practices, whether it's conservation, whether it's sustainable agriculture, whether it's climate adaptation, climate mitigation, reaching upstream and viewing those as levers for health outcomes as well is an important and kind of emerging area of work. And so here's just an example. So this is a system we work with in northern Kenya, looking at, and in this picture you can kind of think from a systems perspective how changes in the environment, whether it's as a result of climate change through more frequent or severe droughts, more extreme rainfall, can have knock-on effects that affect, have direct impacts on disease through, for instance, mosquitoes, ticks, vectors, affect biodiversity, affect animal health, and then this kind of cascade of effects that result in burdens of disease in healthcare centres. And so where EFH is trying to come in is thinking about, well, if you view these different steps as as really levers for interventions, and those interventions can sit, traditionally as they would do for health interventions in healthcare systems, or they could sit upstream in how people manage livestock, how people manage biodiversity, So if you kind of view those in their totality, then returns on investment in these kind of system-wide interventions could be measured through conservation, through social performance indicators, but also through impacts on health and healthcare cost savings, taxable economic output, and and people's overall improved health and well-being. And so how this ties into the topic of this hackathon, and one of the three kind of pillars of work that EFH is beginning to focus on, is how do you there's a lot of scientific work being done on understanding where those levers lie and trying to better understand the evidence to support them. But how do you make that evidence that's mainly contained within scientific publications and data sets and reports, but also held by communities as well? How do you make that evidence accessible to all the different stakeholders who need that information to be able to improve their management of ecosystems, improve their financial products management of ecosystems, etc. So on the right-hand side here, these are all of our potential end users and people who potentially see value in being able to better access scientific evidence that links the environment to health outcomes. And the focus on this sprint is what's the first step in breaking down that evidence barrier and really giving people who work across these sectors access to the right science. And so obviously we're particularly interested in generative AI and as a platform for really making science accessible through natural language. So our aims from an EFH perspective, over the next 3 days, we have two specific aims, and these will tie into the kind of challenges that we're going to give you guys. The first one is, can we develop an interactive tool that leverages LLMs to match design phase projects? So think of this as, it could be a project that Kenyan government or an NGO is developing to look at how to better manage water resources, or how to implement sustainable agricultural development. Or it could be the financial sector document, such as a framework for a sovereign bond or some other kind of financial instrument. So we're really interested in how can LLMs match those kind of early design phase projects with high quality causal science, specifically linking the environment to health, that makes those projects more effective and potentially easier to finance. So that's the first challenge. And for that, we're really interested in looking at, essentially semantic search and RAG with LLMs. So if you have a project design document in the form of a PDF or a document or a Word document, to what extent can the LLM match that with information that's contained within scientific papers? The second day is a similar but slightly different challenge. So this is more focused on data as opposed to scientific publications. So day 2 is going to be about creating an LLM-powered assistant. Think of it as like a digital technical assistant that's capable of automating data querying, visualization, and basic analysis for non-technical users from scientific data sets. And then on the third day, your innovations kind of on these 2 tasks and topics are going to be tested against a set of those real-world documents that we're designing them for. So we've got 3 major organizations represented and coming in. The Nature Conservancy, who are a global NGO. So they're going to provide us with some sustainable development project design documents from Africa, specifically looking at water and the environment and health and economics. We've got, from Nature Finance, I think a $15 billion sovereign bond that was issued for Uruguay. The first sustainability-linked sovereign bond, which focuses on the environment. And so the task there is going to be looking at, how can we better contextualize health as a result? And then from Science for Africa Foundation, some large-scale data sets on scientific research and grant applications to see how well the LLM-powered assistant is able to query those documents and conduct some basic analysis. So so that's the kind of sequence of events over the 3 days. For the first day, as I mentioned, the focus here is on trying to match design phase projects with high quality causal science. So we're going to give you 4 scientific papers to develop those, or to train the LLMs on. And these papers we've chosen specifically because there's global syntheses of different environmental drivers on health and the impact of different interventions on specific outcomes. So there'll be 4 papers, and you can work through them one by one. The first is global change drivers on the risk of infectious disease. So it's kind of looking at biodiversity loss, habitat change, climate change at a global scale and the impacts that that has on infectious disease. The second one is the impact that different conservation actions at a global scale have on biodiversity. The third one is tree-based interventions, so looking at the impact of tree-based agroforestry interventions on health and well-being outcomes across rural, low-income and middle-income settings. And the fourth is looking at the impacts of forests and different forest management schemes on children's health in a kind of similar geographical context. So what links these papers is that they all look at causal evidence and measuring impact from either drivers or interventions on a specific outcome related to health and the environment. And then on day 2, we're going to use the data sets from those papers, which are in CSV format, and then we'll have a series of tasks that kind of test the ability of your systems to query those data sets in natural language and also to conduct some basic analysis using them as well.